Hello, geometry. Starting a new unit, and we're talking about the Pythagorean Theorem. The Pythagorean Theorem is a super common theorem that we use all the time in geometry, especially with right triangles. There's a lot of things that we know. So this is a common proof of why the Pythagorean Theorem works. And so if we take the three sides of a triangle, so we've got side A, side B, and side C. And if we were to draw squares, so again, remember squares have the same distance on each sides. And to find area, you take like length times width, base times height, whatever it is. But again, in this case, because they're squares, it's going to be A times A, which is A squared, or B times B, which is B squared, or C times C, which is C squared. So one of the ways that we're able to prove this is that if we add up the areas of our two smaller legs, so if we add up the area of A squared plus B squared, then it's going to equal the area that is C squared. So again, kind of just a super common classic proof of the Pythagorean theorem. There are actually tons of ways to prove the Pythagorean theorem, but I would say that this is the most common. Things to note, okay? C squared is always your hypotenuse. So I like to think about it as I'm going to take, instead of thinking about it as leg or A, I'm going to say leg squared plus leg squared equals hypotenuse squared. So whether you like to think about it as A squared plus B squared equals C squared, just remember that C squared is always the longest side, which we call the hypotenuse. So if we take a look at this one, again, I have to identify my legs. So across from the 90-degree angle is my hypotenuse, and this is a leg, and this is a leg. Again, if you called it A and you called this one B, this would be C. So whether it's leg squared plus leg squared equals hypotenuse squared, or A squared plus B squared equals C squared, you're going to get 8 squared plus 6 squared equals C squared. 64 plus 36 equals C squared. 100 equals C squared. And to undo a square, you must take the square root, which gives me an answer of 10. So my hypotenuse equals 10 in this triangle. You cannot stop at C squared. We don't want to know what the hypotenuse squared is. We want to know what the actual hypotenuse is. Pythagorean triples are kind of like these examples of just super common Pythagorean like examples that work. So these are ones that you may want to start memorizing, because if you get into a problem and you notice that you have, hey, I've got a side one of my legs is 8 and one of my legs is 15, well, then the hypotenuse is going to be 17. Or if you said, well, I've got a hypotenuse of 25 and a leg of 24, then I know that the other leg is going to be 7. So just something to note about Pythagorean triples is that they are just, I would say, like super common examples where A squared plus B squared equals C squared. This is not an exhaustive list. There are many more of them. So just again, as you start to work through problems and you recognize some of these, you can use that. Using the Pythagorean theorem in real life, a 16-foot ladder, so again, the ladder is this spot right here, rests against the side of the house, and the base of the ladder is 4 feet away from the house. Approximately how high above the ground is the top of the ladder? So again, I need to identify, this is my hypotenuse, this is my leg, I need to find the other leg. So whether you like saying A squared plus B squared equals C squared, or leg squared plus leg squared equals hypotenuse squared, when I fill in what I know, I'm going to say, all right, 16 plus x squared equals, I better figure out 16 times 16 is 256. subtract 16, subtract 16. So you're left with x squared equals 240. And when you find the square root of 240, you are going to get, so again, depending on what the answer is, if it says a decimal, you could say x equals 15 point, I would say 3 decimal places is usually the best. So x equals 15.492. If you potentially had to simplify it into simplified radical. So again, depending on what the directions are, you said, okay, well, I know that this is the same thing as the square root of 24 times the square root of 10. The square root of 10 can be broken up into the square root of 2 times 5, square root of 24, 6 times 4. I know I can pull out the 4, so I have 2 square root 6 times 2 times 5. I may have not done it the most efficient way, so I'm going to kind of 6 times 2 times 5. I'm going to so I pulled out a 2, and I'm going to relook at 60, and I say, okay, 60 I bet I can do 4. So again, 2 times 4 times the square root of 15, and the square root of 4 is 2, so I could get 4 square root 15. And if you typed in 4 square root 15 into your calculator, you get the same answer. So just wanted to show you how you can solve it both ways. Again, if that question doesn't specify, feel free to write your answer as a decimal. If the question says to write your answer as a simplified radical, then you would want to write it as 4 square root 15. So you need to know how to do both. Find the area of the isosceles triangle with side lengths 10, 13, and 13. So again, if this whole side was 10, but I split it in half, that's what this line is doing, is splitting it in half. That's how I get 5 and 5. So to find the height of my isosceles triangle, I'm going to use a squared plus b squared equals c squared, where this is going to be c, this is going to be a, and this is going to be b. 5 squared plus b squared equals 13 squared. 25 plus b squared equals 169. Subtract 25 on both sides. You get 144, and this is going to work out super nice because the square root of 144 is 12. So in this case, the height is 12 of this isosceles triangle. And again, in order to find the area, we need the height. So I'm going to use my area formula, 1/2 base times height. So my base, remember, my base is not 5. This whole blue triangle, the base is 10. So I'm going to say 10 times, and I just found my height was 12. 10 times 12 is 120, divided by 2 gives us 60. So the area is 60 meters squared. So I had to do all this side work to find the height so that I could then use my area formula. Go ahead, pause the video, try this one on your own first. Okay, I'm going to demonstrate. So again, if this base is 30, then that means this is 15 and 15. So if I take my small leg and I square it, plus my height, which I don't know, I square it, equals my hypotenuse is always across from 90 degrees. 15 squared is 225, plus b squared equals 18 squared is 324. So if I subtract these, I get b squared equals 99. Take that square root of 99, and you're going to get b is approximately 9.950, approximately. So then I'm going to take that number and I'm going to plug it in to my area formula. So area equals base times height divided by 2 area equals 30 times 9.95 divided by 2. And 30 times 9.95 divided by 2 gives me 149.25, and my unit is feet squared. There you have it.